Okay, so this is FRQ number 5. I'm gonna draw net force first. I'm gonna draw the free-body diagram for part A. M. So we have Fn, the contact force. We have an F that's acting upon it. We have an F fric that opposes the line of motion, and we have an Fg that goes straight down. For B, you know that Fn equals to Fgy plus Fy. And if you look at the diagram again, boom, you know that we can get the vectors using trig. So you want those two vectors in the y direction. So we know that I'll just move this. The Fn equals to F sine theta plus Fg cosine theta. Means that Fn equals to F sine theta plus Mg cosine theta. That's my answer. C, set net force equals Ma in the F function. Fx minus Fk minus Fgx equals to Ma. We can expand this to S cosine theta using our diagram from before. Fk is just mu k of Fn. And then Fgx is just Fg sine theta. That's all A. I'm going to switch the sides. Expand to so cosine theta. Mu k inside where you found that to be F sine theta plus Mg cosine theta. And then we've got minus out minus Fg sine theta. Then final step, expand one last time and divide by M. So mu k F sine theta plus Mg cosine theta. And this is minus Mg sine theta. And then this is all over M. Okay, now to D. Once again, so they want so constant velocity is when A equals to 0. Whoops. So I'm gonna set up my net force. Net force equals to Ma. So we know that using our formula from above, we already know that A equals to F cosine theta minus mu k F sine theta plus Mg cosine theta. Mg sine theta. It's all over M. When we want it equal to 0, I'm going to distribute the M right now. So F cosine theta over M minus mu k. I'm also going to distribute the mu k. So it's mu k times sine theta is also over M. And this is plus Mg cosine theta. Oh, add a mu k there. So over M minus Mg cosine theta over M equals to 0. Okay. So I'm going to put these two together. So F cosine theta M minus mu k F sine theta over M. And I'm going to move these over to the other side while canceling the M's. So that's, this one's mu k G cosine theta plus G sine theta. I'll multiply both sides by the whole thing by M. Oh shit. Oops. By M. So we're going to get F cosine theta minus mu k F sine theta equals M mu k G cosine theta plus Mg sine theta. And then we just factor out the f. Equals to this. And then we just divide it over. So this m mu k g cosine theta plus mg sine theta. Oops, not that extra theta. Boom. And it's all over cosine theta minus mu k sine theta. So for this to be what is it? Physically meaningful. So we know that f has to always be positive in order for it to move up the slope at a constant velocity. And when we look at the equation above, the only part that could make it negative is this. So in order to make sure that it always remains positive, we can just set cosine theta, which is the one on the left, to be greater than mu k sine theta, because we always want cosine to be greater in order for it to be positive when you subtract the two. And then just divide sine over on both sides, so then you get cosine theta over sine theta has to be greater than mu k, and that's the relationship between theta and mu k. E. This one I'm gonna use the acceleration we found earlier again. So f cosine theta minus mu of f. I didn't say it's k actually, so I'm just gonna boom at mu f sine theta plus mg cosine theta minus mg sine theta all over m. I'll plug everything in. So f cosine 20 minus mu, not mu anymore. This is 0.18 now. No, 0.33. Wrong FRQ. F sine 20 plus 2, 9.8 cosine 20 minus 2, 9.8. This is sine 20. My bad, I have to flip that. Over 2. And this all equals to 0.5. I'm running out of space. So let's simplify everything even further. So 0. So now it's 0.94. Oh, my bad, that's my alarm. 0.94 f minus 0.33 f. I'm distributing the 0.33, by the way. Oops. Yeah, okay, minus is 0.113 f, and then that becomes 6.078, and the other, so this becomes this, and then minus 6.7 equals 1. This becomes this. I just multiply the 2 over to the other side. So I'm going to solve for f, so we get 0.827 f equals to 13.778, and f equals to 16.66 newtons. G, oops, G now. So G, you set it up as f cosine theta minus fk minus fgx equals to 5ma, because we're adding the m's together, Okay, this is net force, by the way, in the x direction. Okay, so F cosine 20 minus Fn mu k minus 5 mg sine theta. Again, it's 5 mg because we had to add both masses of the boxes. It's 5. M we know is 2. A we know is 0.5. Keep solving. F cosine 20. Oh, I'm making my 20s with theta. 20 minus 5 mg. I'm gonna plug in Fn, so 5 mg cosine 20 plus F sine 20 times 0.33, and this is plus I'm running out of space. This is plus 98 sine 20 equals to 5. I need to write smaller. Okay. So I'm gonna move the f's over. Cosine 20 minus, that's 5 originally. Move this one down to the side, so that's plus 5 times 2 times 9.8 0.33 plus F sine 20 0.33. Wow, I still don't have space. 98 sine theta. Now divide by cosine, so 5 over cosine 20, not theta, plus 5 to 0.33 over cosine 20 plus F. So sine divided by cosine is just tangent. Let's write it like that. Shit. F tan theta. Not tan theta, tan 20, you know it. 20 times 0.33 plus 98 tan 20 as well. Because we know that sine over cosine is F. Put the F's together now. So F minus F tan 20 times 0.33, of course, is equals to 5.32 plus 32.34 plus 35.669. F equals 1 minus tan 20 3 not equals, it's just we use factoring out the F. This equals to 73.33. F equals 73.33 divided by 1 minus 0.12, which is what that simplifies down to, which equals 83.33 newtons. H. So F of M onto 4M. So net force again. Minus Fk minus f of g x. And there's another one, so we're going to put in the subscript 4ma. Okay. So f of m for m minus equals to 4ma plus f of k plus f of g x, and then the second one. So which this is equals to 4 times 2 times 0.5 plus fn mu k plus 4mg sine 20. And this equals to 4 plus 0.33 of 4mg cosine 20 plus 4 to 9.8 sine 20. Simplify this down to 4 plus 24.31 plus 26.814. We get F of M, contact force between the two, to be 55.124 newtons. Okay, lastly I. Third block. Okay, so set up the net force for the top block. Net force NA. So the top block, it'd be Fs minus Fgx equals to 2m times A. We know that Fs equals Fn times mu s minus 2mg sine theta equals to 2m. Solution is 0.3, since that's what we want, a constant solution. So Fg cosine theta mu s minus 2mg sine theta equals to 0.6m. Okay. So if I expand this further, 2mg. Actually, I'll move mu s to the front. So mu s 2mg cosine theta equals to 0.6, and we know m is 2. M is 2. I'll add the other one, so that's 2 times 9.8 times sine theta. Simplify this, so mu s times 2 times 2 times 9.8 cosine of 20 equals to 0.6 2 plus 2 to 9.8 sine 20. Mu s of this we don't need that. It's equivalent to 1.2 plus 13.41 over 2 to 9.8 cosine. Cosine. No shit. Whoops. Just equals to that. My bad. And finally, we use 1.2 plus 13.41. We divide that, yeah, that was that. And once we do this, we get mu s. I'll write a nicer one. Mu s equals to 0.397.